Welcome back to Monster Tamer, a 2D Pokemon-like RPG created Phaser 3. Previously, we started working on updating our battle scene to allow us to be able to catch monsters. If you missed the previous videos, there'll be links in the video description to the source code to this point, as well as the complete source code for this video. There'll also be a link to previous videos if you'd like to catch up. So let's get started. So the next thing we're going to work on is now we're going to work on actually adding logic for determining if we should be able to go ahead and catch a monster in our game. So currently in our battle scene, we just have a simple Boolean variable that's hard-coded to say if we captured our monster or not. And so what we're going to want to do is we're going to develop some type of logic that we can apply to our game to determine if we're able to actually catch a monster. And so typically in like Pokemon-like games, there's a variety of factors that can impact if you're able to catch a monster. So a really good resource if you're interested more on this topic is the Cave of Dragonflies. They go over the monster capture mechanics in the various generations of Pokemon. By just some high-level examples of like the different factors that could play effect, is the first is the type of ball you want to use. So in our game, currently we have this damaged ball, which is like the weakest type of ball to be available in our game. And so the chance of that being able to catch a monster would be a lot less than if you had something that was like maybe like a great ball or a ultra ball in the Pokemon type game. Likewise, maybe if you had a type of ball that could always guarantee to catch a monster, it would have a 100% catch rate, then that would also affect that as well. Besides the type of ball you want to use, other factors come into play such as the monster's stats. And so this is like the monster's HP, and so if the monster is fully healed, it's going to be much harder to catch because it's healthy. If it's weak and its HP is low, it'd be easier to catch because it's in a weakened state. Likewise, if the monster has some type of status, like if it's poisoned or sleeped, paralyzed, that also plays a factor in this algorithm that was developed in those games. And then there's other things like on an individual monster's basis, there could be a catch rate that applies to that monster. So as an example, if we're trying to catch a common monster in our game, maybe they're really easy to capture because they're just a weak monster overall, versus if it's like the third evolution of a monster, then it would be harder to catch because it's just stronger. And so there's all kinds of different factors that could play into effect here. And so for our game, we're going to go ahead and make this pretty simple, and then that way we can easily extend this logic later. And we're going to use the monster's HP as our main factor for the algorithm that we develop. But then this could easily be extended further later on to involve things like the item, so that could play an effect. If the monster has a status, maybe if it's like time of day, some monsters are easier to catch at night versus day, and different things like that. And so in the description of this video, I'll include a link to this webpage. There's a lot of good information here if you're interested more in this topic. All right, so go ahead and start working on our code. What we'll do is let's jump over to our source code. Under our utils folder, let's make a new file, and we're just going to call this catch utils. And so this is going to have all of our logic tied to catching our monster in our game. And so the first thing we want to do is we need to go ahead and export out our function, and we're going to call this calculate monster capture results. And so we'll have one argument, and this will be the enemy monster that we're trying to capture. And so what we're going to do for the time being is we're just going to do a very simple logic to get everything working, and then we'll come back to this. And so for being able to catch a monster in our game, what we're going to do is we're going to generate a number within a range. And so for our capture range, we'll do 0 to 100 to keep it simple. And so for this range between 0 and 100, we need to pick some type of minimum value that we need to reach. And that will be the point at, we'll say, anything greater than that, we will capture the enemy monster. Anything less than that, we fail at capturing them. So just as an example, let's say I generate a number and it's 25. Our minimum value could be 50, and since it's less than 50, we'd fail at catching the enemy monster. If we generated another value and it was 65, because it's greater than 50, then the capture was a success. And so to go ahead and do this, we're going to go ahead and add a few variables to our function. And so we'll do const, and we'll do min value required for capture. And we're just going to go ahead and set this to be 80 for the time being. Next, we want to go ahead and generate that random value for our range. And this will be our actual capture attempt. And so for this, we'll do random value. And so this is going to be equal to our phaser math between. And we'll go ahead and do our range between 0 and 100. So now what we need to do is now we need to return if we actually captured that enemy monster or not. And so what we're going to do is we're going to return an object, and we'll do was captured, and this is going to be equal to our random value if it is greater than or equal to that minimum value required for capture, then it'll be true. All right, so the reason we're returning an object here instead of just the Boolean is we need to return additional metadata when we try to capture the enemy monster. So currently in our battle scene, we throw our ball and then we have it shake a number of times depending on how close we're to catching the enemy monster. And so if we're very close, it would shake 3 times and they could break out. If it wasn't very close, it could shake once and then the monster would break out. And so what we're also going to return in this object is we're going to also return our value that we need to reach and our actual capture value, so then that way we can do that animation we're looking to do here. So on this object, we're going to go ahead and return 2 additional properties. And so we'll do required capture value, and we'll set that equal to our min value required for capture. And then we'll do our actual capture value, and we'll set that equal to our random value. And then what I'm going to do real quick, instead of doing 80, this bumped it down to 50. All right, so then what we'll need to do is back in our battle scene, let's go ahead and call our new function, and that way we can go ahead and test it. So what we're going to go ahead and do is right above our was captured, let's go ahead and do const. We'll do capture results. And we'll go ahead and set it equal to our new function. So we'll do calculate monster capture results, and let's go ahead and pass in our active enemy monster. And then what I'm going to do is I'm going to do a console log, and we'll do our capture results. So then what we'll do real quick is let's jump over to our payload scene, and let's jump right into our battle scene so we can do some testing. So now when our scene refreshes, we should be in our battle scene, and let's go ahead and throw our damaged ball. So we'll see we throw it, and we'll see now in our console, we go ahead and see our metadata of our object with our details. And so we'll see that our capture attempt was true because our actual capture value was 81 and our required value was 50. And so we were able to capture the monster. So now what we'll do is let's go ahead and bump this up to, we'll just say 90, so it's very high. Let's go ahead and test that, and we'll see if we fail at catching the enemy monster. So now if we go ahead and throw our damaged ball, what we should see is our capture attempt was false, and because our capture value was 31, but we need to reach 90, we didn't catch the enemy monster. All right, so now we can see that our function is working how we expect. Now we need to go ahead and update our battle scene to actually use those results. So what I'm going to go ahead and do is let's get rid of our console log, and let's get rid of was captured. And so now what we need to do is now we need to figure out how close we're actually capturing the enemy monster. And so what we'll do is make a new variable, do const, we'll do diff in capture. We're going to set that equal to our capture results, and we'll use our required capture value. We're going to go ahead and subtract our capture results, and we'll do our actual capture value. So then what we'll do is let's make a variable to store our number of shakes. So we'll do number of shakes. We're going to set that equal to 0. And so if our difference in our capture is less than or equal to 10, that means we're very close to capturing them. So what we'll do is we'll do our number of shakes, and we'll set it equal to 2. Else if our difference in our capture is less than or equal to 30, that means we weren't quite as close. We'll do number of shakes, and we'll set it equal to 1. And then finally, what we'll do is we'll check to see if we actually captured the monster, and if we did. So if our capture results, and we'll say was captured, we'll go ahead and set our number of shakes equal to 3. All right, then what we need to do is now we need to go ahead and update our play shake ball animation to actually use our number of shakes. So what we're going to do is we're going to wrap this in an if statement, and we'll say if our number of shakes is greater than 0, then we want to go ahead and play our shake ball animation, and we'll go ahead and pass in number of shakes, and we're going to go ahead and subtract 1. And so the reason we're doing that is our number of shakes is the number of times the animation will repeat, and so we just need to subtract 1 to get that value. And then otherwise, we'll go ahead and play our animation, and let's go ahead and set this equal to 0. Finally, for was captured, we want to go ahead and replace this with capture results, and then was captured. All right, and then real quick, what we're going to go ahead and do is I'm going to go ahead and add back in our console log for our capture results, so then we can actually see what we're testing. All right, so once we save, we should go ahead and test. So what we'll do is let's go into our battle scene. Let's use our damaged ball. So after we use our damaged ball, we'll see that our required value for capture was 90. We only had 55, so it was false. So we threw our ball, and the monster broke out really quick. All right, so now what we need to do is we're going to test some of our other scenarios. And so what we'll do is we'll do where we were very close to catching the monster. And so what we'll do for our minimum value, we'll do 90. For our random value, we're just going to say 89. We'll go ahead and save. Let's test that flow. So now what should happen is if we use our item, and so we're going to catch the enemy monster, we should see a couple of shakes. And then the enemy monster breaks free. So then what we'll do is let's go ahead and try a success attempt. So let's go ahead and bump this up to 91. We'll go ahead and save. So we'll go ahead and use our item. What we should see now is we should see our 3 shakes, and then the monster should stay in the ball. All right, so now we've seen our logic's actually working. Let's go and revert our changes in our catch utils. And now what we need to do is now we need to actually add in our logic for calculating that minimum value we need to reach. All right, so for calculating that value, let's go ahead and make a new function inside our file here. So we'll do export function, and we're going to do calculate min value for capture. And so for this, we're going to expect our enemy monster as well for our argument. And then what we'll do is let's go ahead and call this function from our other function, and let's go ahead and pass in our monster. All right, so for calculating that minimum value, what we're going to do is we're going to base this off our monster's HP. And so what we're going to end up doing is we're going to do a very simple function where based on how healthy the enemy monster is, it's going to impact our overall chance for being able to catch a monster. And so just as an example, what we're going to end up doing is we're going to go ahead and if our monster is fully healthy, then we're going to have less of a chance to actually be able to catch the monster. But as we do damage to the enemy monster, that chance is going to go up. And so our logic that we're going to implement is not going to exactly represent these graphs here, but it gets the idea across. So what we'd see here is we'd have like a 6% chance of catching a monster if they're fully healed. If we get them down to 80%, then we have an 8%. Then if we get down to like 60%, we have 18, and so on and so forth till we eventually cap out here. Once we get them down to 32%, we would be at 34% catch rate. And so our logic can be very similar where as we damage our enemy monster, that catch rate is going to go ahead and just keep growing up when we meet certain thresholds. And so to go ahead and do this type of calculation, what we need to do is first we need to determine what our base catch rate is, and that will be our value that we're going to return if our monster is fully healed. And so what we'll do is we'll do const, and we'll do base min. We're going to set that equal to 80, and then what I'm going to go ahead and do is we're just going to return base min. And so this is very similar to like the hard-coded value that we did before. So now what we need to do is we need to go ahead and modify our base min value here to be based on how damaged the enemy monster is. And so if a monster is fully healed, we won't actually take away anything from this value, but if they are at, let's say, 50% of their health, we want to go ahead and subtract something from this value. And the more damaged the enemy is, we want to subtract more, which will result in a lower catch rate for our player. So to go ahead and do this, we need to go ahead and figure out how healthy the enemy monster is. So what we'll do is we'll go ahead and take our enemy's current health, we'll divide it by their maximum health, and then this will give us a value between 0 and 1. And so what we'll do is we'll make a new variable, and so we'll do const, we're going to call this health ratio. We'll set it equal to our monster, we'll do our current HP, we'll go ahead and divide that by our monster, and we'll go ahead and do our max HP. And so with this new value, we can go ahead and modify our base min value. So what we'll do is we'll go ahead and check to see if our monster is less than 25% health. And if so, we can go ahead and remove, we'll do 20 points from our catch rate. So to do this, let's go ahead and do an if statement. So we'll go ahead and do if our health ratio is less than 25%, then we want to go ahead and just subtract. So we're just going to do minus equals 20. And then we'll go ahead and do else. So then what we'll need to do is we'll need to change our base min variable from a const to a let, so we can go ahead and modify the value. So now what we'll go ahead and do is we'll go ahead and do some additional checks. And so what we'll do is we'll add a check for 50%, then we'll do less than 75%, and then less than 90. And as our monster is healthier, we're going to go ahead and take away less from our base min value here. So what I'm going to do is I'm going to go ahead and copy this for our else. We'll go ahead and paste it. And so we'll go ahead and do 50. And then let's copy this. And so we'll go ahead and say we'll take away 15 points. Let's copy this. Oh, we'll change this to else if. Let's copy this block of code. We'll do it one more time. And so we'll say if they are, and then we'll go ahead and do 75%. And so if they're at 75%, we'll go ahead and subtract 10 points. And then finally, we'll have one more check. And so if they are less than 90%, we'll go ahead and take away 5 points. So real quick, what we're doing here is we are going to have a catch rate value that we need to reach in order to catch a monster in our game. And so if our monster is very healthy, then we'll have a higher number, which means a lower chance to actually catch the monster. If the monster is low on health, then we're going to have a lower number, which means we'll have a higher chance of actually catching that monster. And so later on, we could go ahead and enhance this logic to have other factors as well to go ahead and lower our base min variable here. And so, for example, this can include things like status. And so if our monster was poisoned, maybe this would lower the value even more if they were asleep and different things like that. And so before we can actually test our changes, we need to go ahead and update our battle monster class to have a getter method that's going to return our monster's max HP because we only currently have one for our current HP. So let's jump over to our battle monster JS file. And then what we'll do is let's go ahead and copy our getter here for our current HP. We'll go ahead and paste that. We'll go ahead and do max HP. And so we'll do max HP. And we'll go ahead and return our max health. All right, so with that last change, we should now be able to go ahead and test our changes in our battle scene. All right, before I test, one other thing I'm going to do is I'm going to jump over to our preload scene, and I'm going to go ahead and switch to our title scene, and then that way I can go ahead and turn off our animations for testing. I'll go ahead and go into our options. Let's go ahead and set off our animations. Go ahead and save. Go ahead and revert our change back to battle scene. All right, so now I'll go ahead and test. What we'll do is first we'll go ahead and try catching the enemy monster without actually doing any damage. So we're going to throw our ball, and we'll see, oh, 60. Yeah, so in our code, we want to check for a decimal, and so we'll do 0.5, 0.25, 0.75, since we'll have a number between 0 and 1. Okay, so now we should have better results. So now if we go ahead and try catching the enemy monster, what we should see is, all right, so we have a capture value of 80. We were less than that, so we failed to catch. Let's go ahead and do one attack, and so that should drop them down, so they should be into the next bracket. We'll go ahead and use our damaged ball. What should happen now is, yep, so we took off 5 points, and so we didn't reach it, so we didn't catch the monster. What I'm going to go ahead and do is, let's try another attack. And then I'm going to go ahead and heal our monster real quick. And let's go ahead and do one more attack. So now we took in 15 damage, and now we'll try to catch the enemy monster. So we'll see now as we took off 15 points, we still didn't capture the monster. And let's go ahead and try getting one more attack in, and we'll try catching the enemy monster again. We'll see now we took off our 20 points, so now we lowered down to 60, and we did catch the enemy monster. Nice. All right, so one last thing we're going to go ahead and do is I'm going to jump back to our preload scene, and I'm going to go ahead and revert this back to our title scene, and then that way our game will be back in the state we want it to be in. All right, so with that brings this video to an end. So as a reminder, there is a link in the description of the video to the complete source code for this video, and as always, thank you so much for watching. I hope you enjoyed the content. If you did enjoy the video, please consider liking the video and hitting the bell icon to be notified when the next video in the series is released. For more great Phaser 3 content, please follow the links on your screen now.